Bismillahirrahmanirrahim. Assalamu alaikum dear students. Welcome to lecture number 15 of the course. In the last lecture we have started the artificial intelligence and one of the application of AI, the expert systems. Today we'll move forward. We'll talk about the inferencing mechanisms in the expert systems, and we'll see the process of developing the expert systems. Well, inference is the process in which we have facts or rules given in the knowledge base, and we keep chaining the rules together to answer the questions or to solve the problems. So we keep joining all the rules together. We use all the possible available information to apply it on the questions and to be able to answer those questions or to solve those problems. So it is like the mind, the way our brain works, the way our brain processes the information. It is like the brain of the expert systems. Now there are two types of inference mechanism. First is forward chaining and second is backward chaining. In forward chaining, as the name implies, it moves in a forward direction. So in the rules we have if part and we have then part. Okay, so this is the premise and this is the conclusion, right? If is the premise and then is the conclusion. So in forward chaining we start from the if part. Okay, we call it a data driven approach. So if all the conditions in the if part are satisfied, we can infer, we can conclude the information in the then part. Okay, so it means that we start from the if parts of the rule. If all the clauses, if all the premises in the if part are known, we can fire the rule. We'll see what we mean by firing the rule, and we can conclude the then part of the rule. Backward chaining works in a reverse order. It is goal driven technique. It means we start from the then part and then we try to be able to answer the then part or to conclude this from the premises, from the clauses or the if part of the rule. We'll see inshallah an example today, and on the same example we'll see how forward and backward chaining techniques work. Before that, let's see what do you mean by firing a rule. So in knowledge base, which is a long-term memory, this is a general knowledge of the system. So these are all the rules in the knowledge base. Every rule has two parts. We have if part and we have then part. Like if we talk about first rule, in the if part we have two things: if credit score is less than 650 and age is less than 35. Okay, so these are two clauses. These are two clauses or premises, okay, that need to be known to be able to know whether the risk is high or low. Okay, so this is the current problem, the working memory, and we have been given the fact credit score is 600 and age is 20, right? Now in this case, if I look at this rule, both pieces of information, both the clauses, they are known. Credit score is less than 650. It means the first clause is true, and the second, age is less than 30. This is also true, right? So if both are true, then we can conclude that risk is high. So now it means this rule will be fired. It means we can add this fact in the working memory that risk is high. Okay, so this rule is fired, and now this fact is added, risk is high. Now let's say if the credit score was, let's say 700, okay, or the age, let's say it was 40. Okay, so in this case, this clause is false, both are false, So now we will store, the fact will be stored, risk is low. Okay, risk is low will be stored in the working memory, and then we will keep moving forward. So now if you see in the next rule, it's one part is if risk is high. So previously this part was not known, but after this rule is fired, now this part is also known. Now we can use this information to fire more and more rules. We keep doing this till all the rules are exhausted, we have no more rules left in the knowledge base, or till the question is answered or the goal is achieved, right? So based on the facts for the current problem, we fire the rule. We see which rules can be executed for all the rules in which the clauses of the rule, the facts in the if part, they are known. We can add the then part in the working memory. Whether it is true or false, it will depend on the value of those facts, right? So this is what we mean by firing the rule. Now let's see more details about the chaining process or inferencing mechanism, where there are two ways. Backward chaining, it starts from a potential conclusion. We start from the then part, and then we try to seek the evidence from the if part whether the goal is proven to be yes or no. So we start from the then part, we start from the conclusion, and then we try to prove whether the conclusion can be proved to be true or false. And many times it is a goal driven search, so one goal will need more sub goals. Those sub goals, they will need sub goals, and so on and so forth, right? On the other hand, the forward chaining, it starts from available information. So it works in the forward way, the forward direction. If all the clauses in the if part, they are known, then we can draw the conclusions, we can execute and store the then part information in the working memory. To see how they work, let's take a small example. It's a very small example just to show you the working of forward and backward chaining. But of course, in real life situation, we will have much more rules and they'll be much more complicated. But here, let's take a very simple example. So here we are concerned about the investment decision. Let's say someone has got some extra money and they want to get advice about where they should make investment, what is the best investment for them. So these are the variables involved in this decision. So we have A to G, A, B, C, D, E, F, G, 7 variables. A means having at least $10,000, okay, if someone has $10,000 or not. B is regarding age, younger than 30. C is education at college level, and so on and so forth. G is invest in IBM stocks. Each of these variables can be answered as true or false. So in some problems, let's say if the user has at least $10,000, then A will be true. If the user does not have 10,000 or more, then the value of A will be false. Similarly, in certain case, the age of a user, the one who is asking the question, let's say it is 25 or 20 or 18, so B will be true. But if the age, let's say it is 40 or 50, then B will be false, and so on and so forth. So every variable can be answered as true or false, yes or no, based on the value of that variable. Now this is our question. This is the question that we want to answer. The question is, there's an investor who has $10,000, which means A is true, okay, because he or she has $10,000. She is 25 years old, which means B is also true, and she would like advice on investing in IBM stocks, yes or no. So we want to know whether G is true or false, whether she should invest in IBM stocks or not, right? So first of all, the knowledge base, of course, it is developed after consultation with the experts. So this is the way an expert will try to advise her. An expert will use all this information, and he has certain rules or heuristics in his mind that will be used to advise whether she should invest in IBM stocks or not. So what are the rules that a financial expert follows for this kind of questions? First rule is, if a person has $10,000 to invest and has a college degree, then she should invest in securities, right? So this is rule 1. Okay, if a person has $10,000 and has college degree. So if I take you back, having $10,000 means A. So if A is true and a college degree, it means C. So if A is true and C is true, then she should invest in securities. It means E is true, right? So if A is true and C is true, then E is true. So in the next slide, this rule is written as, if A and C, then E. It means if A is true and C is true, then E is true. Similarly, the second rule is, if the person's annual income is at least $40,000 and has a college degree, then she should invest in growth stocks. So having income of at least $40,000, it is D. Okay, so if D is true and a college degree, C is true, then she should invest in growth stocks. Growth stocks is F. So if C is true and D is true, then F is true. This is the second rule. If C and D, and they are ended together, so the order doesn't matter. If D and C or C and D, it doesn't matter, then F is true, right? Similarly, next rule, rule 3, 4, and 5, you can see all of them, they use these variables A, B, C, D, E, F, G. So this is the knowledge base. Rule 3 is if B and E, then F. Rule 4 and 5, right? So these are the rules in our knowledge base. First, let's see how this question will be answered by using backward chaining algorithm. So this is the question, okay? This is the question we saw before, okay? From the question, we can say that A is true. This is the case fact. We can say B is true because the investor has at least $10,000 and she is 25 years. So A and B, they are true. We want to know whether G is true or not. Our goal is G. What is G? Whether G is true or not. If G is true, she is advised to invest in IBM stocks. If G is false, she is advised not to invest in IBM stocks. Let's see how backward chaining works. Backward chaining is goal driven. So we want to know, our question is G. So first of all, check in the case facts whether G is known or not. Now we know that A and B, they are true. We do not have information about G. So what we do, we go to the knowledge base, and now we find the rule in which G appears in the then part as a conclusion. So this is rule number 5, because G appears in the then part. So this is our goal, okay? It is a goal driven search. So now we see what is in the if part. In the if part, we have F. So now check in the case fact, F is known or not. Now F is not known. We only know about A and B. So what happens? G can be answered by knowing F, but F is not known. So our second goal is F. Now look for the rules in which F appears in the then part. We have two rules, rule 2 and rule 3, right? So it can be answered either by rule 2 or by rule 3. What is rule 2? Rule 2 says that if C and D, they are true, then F is true, right? So F is our goal and we want to know the value of F. So C and D. Now D is again D is not known, and we do not have any rule in which D appears in the then part. So expert systems, how do they behave in this case? In this case, there are two ways. One is the system can prompt to the user to ask about D. So we can check the variables. What was D? If you see the variables, D was annual income of at least $40,000. So the system can prompt the user, is your income at least $40,000? If the user says yes or no, based on that we can conclude C and D, okay, and so on, and then we can conclude F and then G. But the other way is, it is not known, so follow the other path, which is rule number 3, B and E. Okay, so if we know B and E, we can answer F, and if we know F, we can answer G, right, which is the goal. So B and E, B is known, okay, B is true, E is not known, so E becomes a new goal, right? So for E, now again look for a rule in which E appears in the then part. It is rule number 1. Rule number 1, E appears in the then part, and what is in the if part? A and C. So E is our new goal, okay, and how it can be achieved by knowing A and C. A is known, C is not known. Okay. Now look for a rule in which C appears in the then part. This is rule number 4. Rule number 4 contains C in the then part. Now C is the goal, and it only needs information about B, and we know that B is true. It is in the case fact. Now if B is true, C is also true. So now this rule will be fired, and in the case fact it will be added this fact, C is also true, right? Now if A is true and C is true, then E is also true. So now this rule will also be fired, and in the case fact E is true, this is also added. Now if E is true and B is true, then F is true, okay? So now we know B is true, we know E is true, so now this rule can also be fired, rule number 3. Rule number 3 is also fired, and now F is true. This is added in the working memory. And finally, if F is true, then G is true. So F is true, the rule number 5 states that if F is true, then G is true. So if F is true, so we can say that G is also true. So we have achieved the goal, right? So we can say that the answer to her question is yes, you should invest in IBM stocks. I hope you get the basic idea. We start from the question and we look for a rule in which our goal appears in the then part of the its then part. Then we try to look for information in the if parts. If it is available, we can fire those rules and we can conclude the then part. If it is not available, then it becomes a new goal, and then we look for the rules which contain this new goal in the then part. We keep doing this till all the rules are exhausted or we have answered the question, right? So in the intermediate steps, if some information is missing, the user may be asked to provide that information to be able to draw the conclusion or answer her question. This is backward chaining. This is how it works. Second, let's see how the forward chaining mechanism works. Same question, same knowledge base, and now let's see how the forward chaining mechanisms work. So A is true and B is true. This is given, and the goal is to know G, okay, whether G is true or false. So it starts from the first rule. If A and C, it is data driven, so it starts from the first rule, A and C. Now A is known, C is not known, so we cannot fire this rule. This rule cannot be fired. The second rule, if D is true and C is true, then F is true. D and C both, they are not known. This rule cannot be fired either. Next, B and E. B is known, but E is not known, so this rule also cannot be fired. Next, rule number 4. If B is true, then C is true. Now B is true, this rule can be fired, so now this information is added. C is true. So this was first iteration. In the first iteration, we got these 3 facts. A and B were given, and the C is true. This is iteration number 1. Now the second iteration will start, because now we have more information available, so maybe some more rules can be fired. Okay. So now in the second iteration, this rule 4 is fired, so it will not be considered in the next iteration. It is already fired. Now in the next iteration, rule number 1, if A is true and C is true, then E is true. In the previous iteration, the value of C was not known, but now it is known. So A is true, C is also true, so this rule will be fired, and in the second iteration, E is true. This information is added in the working memory. Okay. Now next rule, if D is true and C is known, but D is still not known, so this rule cannot be fired. Rule 1 is already fired. Now rule 3, if B is true and E is true, then F is true. In the previous iteration, again, it could not be fired, but now B is known, E is also known, so F is true. This fact is also added. This rule is also fired, right? And finally, F is true. This rule can also be fired, so we can conclude that G is also true. So again, we have arrived at the same conclusion, that the person should invest in IBM stocks, right? Now I hope you can see the difference, how they work. If you see the backward chaining algorithm, it was working from goal to the premises, but here if you see, it is working from the premises to the goal. If you see the arrow directions, they are going from the premises to the goals. It is the forward chaining algorithm, or forward chaining inference mechanism, right? So in this case, same answer was achieved, and the same sort of rules was used. Both were equally applicable, but in certain cases, forward chaining might be better as compared to backward chaining. So you may ask, how should we choose whether backward chaining or forward chaining for a particular problem? This is the first inference issue. We'll talk about several of them today. To decide between forward and backward chaining, follow how a domain expert tries to answer your questions, how they solve these problems. If the expert collects the data and then infers from it, then we should use forward chaining. For example, let's say you want to make a system for zakah calculation. We all know that every Muslim pays 2.5% of his or her belongings or savings at the end of the day to the poor or needy people. So if you go to an Islamic scholar, a sheikh, and you ask him or her, I want to pay zakah and I want to know how much I should pay. Now the scholar will collect all the information from you. He will ask you how much money you have, how much jewelry you have, how much piece of land, business, and so on and so forth. And then he will do all the calculations and he will say, you should pay this much amount of zakah. So this is a problem more appropriate for forward chaining, because the expert collects all the information and then gives the answer. On the other hand, some experts, they start with some hypothetical solution. They start with certain assumption and then they try to prove it to be right or wrong. In those type of problems, backward chaining is the more appropriate algorithm. For example, medical doctors. If you go to a medical doctor, you have certain symptoms. Let's say you have high fever, you have high blood pressure, and so on and so forth. Now the doctor, based on your assumption, he will build a hypothetical solution. It means he will think, okay, you may have disease A, B, or C. Then he will propose certain medical tests for you, and then based on those medical tests, he will rule out certain diseases, and then he will try to prove whether a disease is there for you or not. So this is more like a troubleshooting. Mostly the troubleshooting kind of problems, they are more appropriate for backward chaining, in which we start with certain hypothetical solution that you may have this, and this problem which have these solutions, and then we try to rule out the possibilities to arrive at a conclusion, right? So this is how we can choose between the backward chaining and forward chaining techniques. For certain problems, both may be valid. Like the simple example we saw, it was easily and equally applicable in both the cases, but for certain problems we may have to pick between forward and backward chaining. So this is how we can do that. The second issue in inferencing is how to handle conflicting rules. Sometimes the rules, they have certain conflicts. Let's say here, this is a very simple example. If A is true and B is true, then C is true. Another rule says if X is true, then C is false, right? Now if I follow, let's say A, B and X, all of them, they are true. If I follow rule 1, it says C is true, and if I follow rule 2, it says C is false. So which one to choose? There are many ways in which we can handle these conflicting rules. First of all is establish a goal and stop firing the rules when goal is achieved. So whichever of these rules was fired first, we accept that answer. This is first solution, first way of handling. Second is we use the rule which has highest priority. In rule-based systems, in expert systems, we can also attach a priority with all the rules. Let's say I attach a priority from 1 to 10. 10 is the highest priority, 1 is the least priority. So let's say the priority of rule 1 is 5 and the priority of rule 2 is 9. So now in this case, this rule is more trustworthy because it has a higher priority. Okay. Another is find the most specific rule. If by specific we mean a rule that uses more information. Okay. For example, in these two rules, rule 2 is using more information. Rule 1 is using more information. It uses 2 facts, but rule 2 it uses only 1 fact, right? So in this case, rule 1 is more trustworthy. We will accept this solution. We'll say that C is true, right? So the rule having more clauses, the rule which has maximum number of clauses in the if part, it is more trustworthy because it is using more information. The intuition is that it is using more facts, it is using more information, so it should be more trustworthy. Still another way is to find a rule which uses the most recent information. So if there is a rule, let's say in case of rule 1, A and B was added previously, but X is added most recently, it is the most recent information, then we will trust this rule. Okay, so again this one way. And the last is both answers are presented to the user with the trace of rules followed to arrive at this conclusion. So another way of handling the conflicting rules is we present both answers to the user and we ask them to choose. I mean, we can tell them that if we follow these set of facts, then this is the answer. If we follow these set of facts and these rules, then the answer is this. So the choice is for the user. Both answers and their justification is presented to the user. Okay. So coming to the justification, explanation, it is very important in expert system. Just like the human beings, they can justify their actions or their answers or their advice or their solutions. Similarly, the expert systems, they also have a justifier component which can justify or which can explain its conclusions. There are many purposes. It makes it more understandable for the user. It can be used in debugging. It increases user confidence. It can be used for more analysis of the system to look for any unanticipated situation. So there are many quite intuitive justifications for explanation purpose. So it can be built into a expert system that can justify its answers. There are two types of explanations. Why explanations explain why a certain fact is required. Just like in the previous example, we saw that the user salary information was not available. So we could have asked the user and we could have given an explanation why this fact is required, because without this fact we cannot arrive at a conclusion. It is required for this rule, and then this rule will be used in this way to answer your question. So these are why explanations. And second, more commonly and more importantly, are how explanations, which justify how a question was answered. What trace of rules was followed to arrive at the conclusion. So you can simply explain the last step, or you can provide a complete chain of all the rules to present to the user so that they know how the question was answered. Coming to the second part of the lecture, we'll quickly go through the development process of expert systems. This is a typical process. First of all, we need to acquire the knowledge from the experts. Then we need to represent it in a computer understandable format. Then we need to select development tools. Okay, what tools will be used to implement the system. We develop a prototype, we evaluate it, and finally we have some improvement or maintenance cycle for the system. We'll quickly go through all these steps. The first thing, just like in any system, is to define the nature and scope of the problem, right? Mostly expert systems, they give better results if the problem is kind of qualitative problem. The knowledge is easily available from the experts, and it is a narrow problem. Mostly the expert systems, they work better if the problem is very narrow, very well defined. So for more broader or larger problems, expert systems do not perform really well. Next, we need to identify the experts who can help us in giving the knowledge, right? So these experts, they should have good experience, they should have good expertise, they should understand the expert systems and how this technology works, not like the technical details, but a brief idea, and they should be willing to help you, and they should have good skills to communicate or to transfer their knowledge to the knowledge engineer. Knowledge engineer is the most important guy in developing the system. His job is to acquire the knowledge mainly from experts, but he may use the other sources as well, as we discussed in the last lecture, to develop the knowledge base and inference engine of the expert system. And the discipline that is related to this is called knowledge engineering. Next is to select the building tools. We can develop any expert system by general purpose development environment. You know that expert system is nothing but a chain of if-else statements. All the rules, they are represented in the form of if-else statements. Of course, there are more things. You can also have priority of the rules. You can have different ways of handling the rules, the chaining the rules forward or backward. But actually, at the heart of expert system, they are just if-else statements. So any general purpose development environment can be used to develop expert system. Like if you are comfortable in Java, you can use Java, you can use Python, you can use C, you can use .NET, you can use any environment, any general purpose environment for developing expert system. However, there are also some expert system shells available like Axis, Corvid, CS Builder. These are some of the well-known shells. So these are specialized programs for developing the expert system. They can handle large number of rules. They can handle all the specialized features of the expert system. So you just need to plug in all the rules and do not worry about how the rules are handled. It is just like, to have an analogy, we can say that like a DBMS, we just put all the data, how the data is stored, manipulated, access, write mechanism, and so on and so forth. It is handled by DB engine. Similarly, the expert system shell, it provides you a way of putting all the rules in it, and then you do not need to worry about how those rules are managed and executed. So it is like a shorter way of developing the system, but be careful. Some of these shells, they are very, very expensive. Some free tools are also available, but mostly they are very expensive tools. So next is the coding or implementing the system. Whether you have chosen the general purpose tools or any expert system shell, now you need to put in all the rules in the system, and you have to make sure that there are no bugs or errors in the system. Next step is to assess the expert system. We have three types of assessment: evaluation, verification, and validation. Evaluation, as the name implies, it assesses an expert system's overall value, okay, the effectiveness, analyzes whether the system would be usable, efficient, and cost effective, right? Validation deals with the performance of system compared to the expert's performance. So the experts, they answer your questions, they solve your problems. So how does the expert system compare with the human experts? Was the right system built? The system that we built, does it solve the correct problems or not? So maybe you did not identify the problems correctly. Maybe the knowledge base is not developed for solving the right problems, right? Is it accurate or not? And verification is, was the system built right? The algorithms, the rules that we have given in the system, are they right? Are there any bugs, errors? So there is a difference between validation and verification. Validation is, are you solving the right problems or not? Verification is, you are solving the problems in the right way or not, right? So validation is more about problem analysis. If you did not identify the correct problems, even if your algorithm is correct, still the users will not be satisfied because it does not solve their problem. Verification is about solving the problems in the right way. So it is more about the bugs or errors in your system. Okay, so there should be no mistake in developing the system. The system should be implemented according to the specifications. Right? There are many problem areas addressed by expert system. There are many applications of expert system. Some of them are given here. Of course, we'll not go into details. There are thousands of applications in which expert systems they are used. Similarly, expert system benefits, most of these things, they are obvious. We discussed in the last lecture also. So you can go through them by yourself. They capture scarce expertise from, because mostly the human experts for every domain, they are few. So expert system, they can make these expertise more commonly available to common user. So in this way, they can improve the productivity, they can improve the quality, the decision-making time is reduced downtime. The human beings, they need to take rest, then their concentration may be lost, they get tired. Okay, so all these things are not there. Easier equipment operation. Again, if human beings they use certain equipment, the cost will be much higher and tedious. But if the expert systems they are used in certain tasks, they will improve the efficiency. So all these benefits are there. Some of the problems and limitations of expert system, again we'll quickly go through them. Most of these things are pretty obvious, but we'll quickly go through them. Knowledge is not always readily available. Many times the experts, they are difficult to get, they are hard to communicate, and it is difficult to get the knowledge from them. It is not easy task. So knowledge is not easily available, or sometimes experts they are not willing to share their experience. There is fear, or there is some conflicts. Every expert has his or her own opinion. So if you get information from many sources, there are conflicts. Another limitation is these systems, they work only in narrow domain of knowledge. We discussed before that for broader or for bigger problems, expert system performance is really low. Experts' vocabulary is often highly technical. To be able to talk to the domain experts, you need to have some domain knowledge. Again, it is a challenging thing. Knowledge engineers, they are the most crucial component, they are the most crucial actor in developing expert system, and they are also rare, and these guys are also very expensive. And many times the end users, they do not trust the expert system. Just imagine that if a medical doctor advises you for something, what would be your level of trust? And if you get some recommendation from a computer program, what would be your level of trust? So of course, we trust human beings much more as compared to the system. And the last thing is the expert systems, they may also make mistakes. We have discussed this before as well, that just like human beings, the expert systems, they can also make mistakes. So these are some of the benefits and drawbacks of expert system. We have learned in rather detail about the expert systems, how they work, the internal working of these systems, the areas in which they can be applied, certain limitations and drawbacks of these systems. That is the end of today's lecture. See you inshallah in the next lecture. Assalamu alaikum wa rahmatullahi wa barakatuh.